going to study chemistry subject, and this is session number 7 belonging to the same chapter whose name is Aliphatic hydrocarbon. Now up till section number 6 we have been gone through certain preparation method, but actually in section number 6 I was stuck with the two topic wherein it was dealing with the Markovnikov rule and anti-Markovnikov rule, wherein we are using the reactant as an alkene, and by addition of hydrogen halide we used to prepare two products which are nothing but the major product and the minor product by applying certain rule called as Markovnikov rule, as well as an anti-Markovnikov rule that was reverse, exactly reverse of that. But now session number 7 we are going to emphasize upon a certain topic which was left, wherein the preparation of alkene we are going to study, right? So the preparation of alkene by a process called as reduction of alkyne, right? So here the reduction of alkyne will be going to take place in order to prepare olefin. Now how this process will be going to take place, let's study over here. Now here we'll first write down the certain statement, and then by taking certain general reaction and example will understand in more precise manner. Okay, so let's write down the statement and understand that in step by step manner. So the statement is like that: when alkyne, now here reduction is going to take place. The reduction of alkyne will be going to take place in order to prepare the alkene. So when alkyne is reduced, when alkyne is reduced by using metallic sodium in liquid ammonia, that time we are going to produce, or it will yield the alkene, but that will be going to get produced in one form called as transform, right? So what is that transform and cis form? I'll make you understand by taking the general reaction over here, right? So here what is happening is that when alkyne is reduced, okay, by using metallic sodium in liquid ammonia, it will yield alkene or olefin, but in transform. So what is this? Let's understand by taking the general example over there. So what is here they are saying is that the alkyne is undergoing reduction. The alkyne has to reduce in order to obtain an alkene. Okay, so which form it is? Transform. Okay, so here the alkyne has to undergo reduction in presence of sodium, metallic sodium, and thus too they have to pour into a liquid called as ammonia, right? So let's understand by taking the general reaction. Now general reaction we'll write down here. General reaction. Now here the alkyne will have the functional group so called as like this: R bond C, triple bond C R. Means here the two alkyl groups are present in the periphery, and the triple bond will be going to get present between the carbon-carbon atom. Means the triple bond is going to get present between this long chain, right? So that is the meaning of the word alkyne. So this is an alkyne. The functional group for the alkyne is R, C, triple bond C, R. So two alkyl groups are present in the periphery, and the triple bond will be going to get present between the two carbon atom. Thereby it is considered to be the alkyne. Now this alkyne will be going to undergo reduction. Okay, so this is the partial reduction. This is the partial reduction. Partial reduction means incomplete reduction will be going to take place over here. Okay, so here one more word I would like to add over here. When alkyne is reduced, or when alkyne is partially reduced, okay, partially it will be undergo reduction, so that time it will yield. Now it is undergoing reduction in presence of metallic sodium, and that is going to get added into liquid ammonia. So that time you are going to yield the product so called as alkene. Okay, now alkene, we know that alkene is also unsaturated hydrocarbon, but in alkene double bond is going to get present. Now here the triple bonded compound will be going to get break down to form a double bonded compound, right? So here what will happen, the two hydrogens from that medium will going to get combined with this alkyne. Okay, so because of the combination of the hydrogen molecules, this triple bonded compound will be going to get break down, and it will yield the trans form of an alkene, which is written in this form. So so the trans form means what? I'll make you understand. It's very simple one. So this carbon-carbon triple bonded compound will be going to get broken down into carbon-carbon double bond, and here what will happen is that the two alkyl groups are there, no? These two alkyl groups are present in the opposite side. They are going to get present in the opposite side, and the two hydrogen, because alkene is consisting of two double bond over there. So there, this one bond will be going to get break down, and the two hydrogen atoms which are present in the medium, they are going to get combined in the opposite side of the chain, right? So this opposite sides of the chain will be going to get accompanied by addition of hydrogen atom from the liquid medium. Okay, so this is what called as trans form of alkene, right? So here the alkene is formed, which is present basically in the trans form. Trans form means what? The two hydrogen atom will be going to get combined to the carbon-carbon double bonded in opposite fashion. Okay, so that was all about the stereochemistry of the alkene, which is formed when alkyne is partially undergoing reduction in presence of metallic sodium, basically in the liquid medium, liquid ammonium. Okay, so let's talk about the another alkene formation. Now this type of a reaction where metallic sodium is taking in presence of liquid ammonia, so that this type of a partial reduction is basically called as Birch reduction. Okay, so this type of reduction is basically called as Birch reduction, where the alkyne is undergoing partial reduction in presence of sodium, and that's why they are adding into the liquid ammonia to form a trans form of alkene. Okay, now let's talk about the another form, which is called as cis form. Okay, so let's talk about the second point. Now here what will happen, here also the alkyne will undergo reduction, partial reduction, basically a reduction with the help of hydrogen, using a catalyst, called as palladium. Now here the alkyne will undergo partial reduction by using a catalyst, right? Palladium, basically here hydrogen is used as a reduction, right? So hydrogen is going to get utilized in presence of a catalyst called as palladium. So in order to yield the product called as alkane, in cis form, basically in cis form, right? So in cis form the product will be going to get formed. So what is the meaning of the word cis form? How that alkyne will undergo reduction by using hydrogen in presence of catalyst. Let's understand here. So here the same alkyne, okay, the same alkyne will undergo reduction by using hydrogen gas in presence of palladium. So this time the alkene will not going to form in this manner, right? The result of this product will not going to be having the trans form, it will have a cis form. How that cis form will be going to get formed? Let's see over here. So this carbon-carbon triple bond will be going to get broke. Why? Because the two hydrogen atoms which are present over there, they are going to get combined and thereby the alkene will be going to get formed. So here the carbon-carbon double bond will be going to get break and it will form a carbon-carbon double bond, and the two hydrogen from this which is used as a main reactant, that will add in the same side. Now in the transform, how the two hydrogen was adding in the opposite side has a stereochemistry. Similarly here what will happen, the two hydrogen atom, they are going to get add in the similar side, wherein in transform they were adding in the opposite side. So they are going to get add in the similar side, and the two alkyl groups, R group, they are going to get present in the same side as well, right? So the name of this alkene which has formed, basically it will possess the cis form of stereochemistry, cis form, okay, cis form. So this is how the alkyne will undergo reduction by utilizing two important components over there. First one is the alkyne will undergo partial reduction in presence of sodium, metallic sodium, in liquid ammonia to yield a product which is having a transform, right? Similarly, and this type of reaction is basically called as where liquid ammonia, metallic sodium is used in the liquid ammonia. That time this type of reduction is called as a Birch reduction. Understand this word, Birch reduction. Whereas in second step, the second formation is the cis form, where the alkyne will undergo partial reduction in presence of hydrogen by utilizing certain catalysts, so called as palladium, to form an olefin with cis form of stereochemistry. So thereby this is the general reaction. Okay, now let's take the example how we understood by taking a general reaction. We'll take one precise example, we'll understand more deeply over there. So the example is that as such. First example we'll consider. So we are going to take the compound whose name is butane basically, but at 2 and 3 position of carbon chain, the ine means triple bond will be going to get present. That is the meaning of the word but-2-ine. Okay, so here the formula, the structure formula is there. So this is carbon number 1, carbon number 2, and this is carbon number 3. Now between carbon number 2 and carbon number 3, the ine means the triple bond is going to get present, and thereby we took the lowest preference, so called as 2, right? Then but means what? Butane, 4 carbon is there in the long chain. So here 3 carbon is done, then the remaining 1 carbon will be going to get satisfied by attaching with the 3 hydrogen atom. So this is what the structure of but-2-ine. Okay, so which is a butane. And now here these two steps wherein we studied. First step was Birch reduction, the second step was the catalytic reduction. Okay, in first step what was happening, the alkyne was undergoing partial reduction in presence of metallic sodium, that's true, they are taking in the liquid ammonia to form a transform of olefin. Okay, so here this alkyne, which is so called as but2-ine, will undergo first the catalytic reduction in presence of metallic sodium, and thus too they are taking in liquid ammonia to form a transform. Now how the transform will be going to get formed? The two alkyl group, they are going to get present in the opposite side. Remember the general reaction. Alkyl group means what? It is a sister of alkane where one hydrogen will be less into that alkane. If one hydrogen you remove from the alkane, what is left is alkyl. I repeat once again, this is a alkane. Okay, if one hydrogen you remove from the alkane, what is left? It is left with alkyl group over there, right? So here what is happening is that this but2-ine will undergo the partial reduction. So the two alkyl group, which are the two alkyl group? 1, 2, right? So this two alkyl group, they are going to get present in the opposite fashion, and here you are going to produce the alkene, right? So here the triple bonded carbon compound will break down to form a double bonded carbon compound. So this one bond which is there, that will be going to get break down, because in that place the two hydrogen will going to get combined into that carbon-carbon triple bonded compound, right? So the two hydrogen you are going to get from that liquid ammonia medium, and thereby this carbon-carbon triple bond will break down and it will form carbon-carbon double bond, and this two methyl group, the two methyl group, methyl number 1 and methyl number 2, right? So this two methyl group, methyl number 1 and the methyl number 4, basically the two terminal methyl group, they are going to get present in transform, means they are going to present in the opposite fashion. So this two methyl group, they are going to get present in this opposite manner, and the remaining two bonds, they are going to get acquired with the two hydrogen atom, and that two hydrogen atom again they are going to get attached to that carbon-carbon double bond in opposite side. Okay, so this two hydrogen atom, they will going to get attached in this manner. So what you formed over here? We formed an alkene whose name is again butene, right? So which is present in the transform. It is present in the transform. Okay. Now if we take the partial reduction in presence of hydrogen, and that's true, the catalytic reduction you are taking place in presence of palladium, so that time you are going to get form an olefin which is exactly opposite that of transform. Here what will happen? The two methyl group, they are going to present in the same side, and the two hydrogen will be also going to get attached to that carbon-carbon double bond in the same side. Okay, so here the triple bonded compound carbon-carbon will break down, and the two methyl group, methyl number 1 and methyl number 4, they are going to present in the same side along with the two hydrogen atom. So this is the cis form of butene. This is the cis form of a butene, whereas that is the trans form of a butene with two methyl group will be present in the opposite side. Okay, so from alkyne you are manufacturing, you are producing alkene, but in the two stereochemistry form. First one is the trans form, second one is the cis form. Okay. Now suppose in place of methyl, if I took ethyl, in place of this methyl, suppose if I took 2-ethyl like this. So what I am doing is that I am changing the alkyl group. I am just simply changing the alkyl group. So if 2-methyl group was replaced by the two another alkyl group, so called as ethyl group, so the name of this will become as 2, 3, 4, 5, 6. 6 carbon oriented compound it is, right? So the name will be as such hexyne, but 1, 2, this is 3, 4, 5, 6, right? So hexyne, ion, but at position 3 and 4 it is present between the carbon number 3 and carbon number 4, the triple bond is present, so thereby the lowest preference for that is hex 3 ion. Right, now this time what will happen? Simply, yes, the similar reaction will be the same way, but here what will happen? The two alkyl group in the transform, it will orient or position themselves into the opposite side, right? So here the two alkyl group, so called as ethyl group, it will orient in the opposite side in the transform, whereas in cis form the two alkyl group will be present in the same side. Okay, but one more thing, additional thing I would like to say, whatever the transform of a product which has been formed over there, they are quite stabilized because the two bulky groups, two alkyl groups, they are present in the opposite side, right? So here, if they are present in the opposite side, two bulky group, the molecule will be quite stable. If suppose two bulky group, two heavy group, they are present in the same side, there will be steric hindrance, right? Because the position is less and they are trying to position themselves within that carbon-carbon bond in the same side, there will be certain hindrance between them and the molecule will be not that much quite stabilized. Right, so that is an additional information. So this is all about the reduction of alkyne, okay, by utilizing first one Birch reduction, second one catalytical reduction. In catalytical reduction you are going to use palladium in presence of hydrogen, and in Birch reduction the metallic sodium are going to get used in presence of liquid ammonia. In this Birch reduction the transform of product will be going to get formed, whereas in catalytical reduction cis form of product will be going to get formed. Okay students, now let us study the next topic. Its name is ozonolysis. Now this is topic wherein you have been already studied in your 12th standard. It's really easy and very interesting, as well as it is very important from your examination point of view also. Now here the ozonolysis is what? Here the most important molecules so called as ozone will undergo lysis. Lysis means breaking. So ozone is having a molecular formula so called as O3. So this will undergo lysis, a breaking. After getting break up, it will get added with the olefin to form a certain unstable addition product which is called as ozonol. Okay, so how this is going to be formed? First, let's write down the statement manner and understand with the help of reactions. So here what happens, children, is that first the ozone, this O3 molecule will undergoes reaction with olefin. Olefin is what? Olefin is alkene. Olefins in an inert solvent. At low temperature. In an inert solvent at low temperature to end or to produce, okay, to yield an unstable addition complex, I can say, called as ozone. Okay, so here what is happening is that ozone will undergo reaction with olefin in presence of an inert solvent at low temperature to yield an unstable complex called as ozone. Okay, so here certain big words are there. They are very simple, but let's understand by taking an reaction. Okay, so here the ozone plays an important role thereby. The name is ozonolysis. Why the ozone is taking part? Because the ozone has to cleave itself to get combined with the olefin. Now olefin is an alkene. So if I have to take an olefin. Okay, now if I am taking an olefin, it will have a triple bond. Okay, but I am just writing in this vertical way rather than writing in the horizontal way. The molecule I am just writing in the vertical way. So this is an olefin and alkene. Okay, and when this alkene is getting combined with the ozone O3, the addition reaction is going to get happen. Addition is happening. Okay. Now after getting addition, so here what is happening? O3, right? So this O3 will be going to get combined with this olefin in such a manner that the bond will be going to break between the carbon-carbon double bond. The double bond is there, right? So that double bond will be going to get cleaved, and this ozone will be going to get attached to that olefin. So after getting attachment, the structure will be like this. The structure is there. The bond is going to get cleaved, right? This double bond is going to get cleaved, and this O3 molecule will be going to get combined in this manner. Now this is really very unstable. So being an unstable, it will further undergo rearrangement process. In rearrangement process, what will happen is that the 3 oxygen atoms which are there in the between in this triangular form, they will get rearranged by having the resonancing effect over there. The shifting of electrons will be going to take place, and that is the mechanism basically. So this 3 oxygen atom will be going to get rearranged between that carbon-carbon bond. So here the rearrangement process will be going to happen. Rearrangement. So in this rearrangement, these 3 oxygen atoms are there. They will get rearranged in this manner. So one oxygen atom will go and get combined between this carbon-carbon bond, and another 2 oxygen will be going to get combined in this manner. Okay, so this is the molecule whose name is ozonoid. This is ozonoid. Okay, now how the ozonoid is formed? Very simple, it is alkene when it is treated with ozone, or ozone when it is undergoing reaction with an alkene. The double bond which is there in the alkene, that will get cleaved, and the addition product is, it will form the product in this manner, and this product will undergo further rearrangement process so that the 3 oxygen atoms will get situated in that manner. But whatever the product it has formed in the form of an intermediate, it is quite unstable, but it is highly unstable, I can say. And this ozonoid which has been formed, it will not going to stay in isolated form, right? It will further undergo the reaction process. Now whatever the ozonoid has been formed, so let's write down in the statement form again. So till this I think you guys have been understood. So whatever the ozonoid has been formed, that will not going to stay in that manner. It will undergo further reaction with the another component. Okay. So with which component it will go undergo reaction? Let's see that. So this is basically 2-step reaction. It is not a one-step, single-step reaction. It is a 2-step reaction. So in first step, the ozonoid or the unstable addition complex will be going to form, and that unstable ozonoid will undergo further reaction with certain another component to form the another product. Okay, so in second step, what happens is that the ozonoid being an unstable complex, unstable addition complex, it will undergo further treatment with what? further treatment with boiling water, or zinc, and sorry, or not, I'll use the word and here, or here, this unstable ozonoid which has formed, it will undergo further reaction with boiling water and zinc, or zinc and acetic acid. Zinc and acetic acid. So what is happening over here? The ozonoid which has formed, it is being a quite unstable molecule. So here what happens is that it will further undergo a reaction with boiling water and zinc, or the another component is zinc and acetic acid. So whatever it is written in the statement form, you just have to keep in the reaction form. Understand this? Whatever the things are there in the statement, you just have to put properly in the reaction form. So let's write down the second step. So this is the first step. Now in the second step, yes, that ozonoid, the addition complex, we'll draw once more time. So here, so this is the ozonoid. Okay, now this ozonoid, which is being unstable, it will undergo reaction with either two ways. In first way, it will react with the boiling water and zinc. Yes, here we wrote. It will react with the boiling water and zinc. First, will react that ozonoid with the boiling water and zinc. So once it is getting reacted with the boiling water and zinc, it will form an important component which is called as carbonyl compound. Here, the two carbonyl groups will be going to form. Now, the functional group for the carbonyl group is this way. So, this is the functional group for the carbonyl compound. Okay. So, here, the two carbonyl compound will be going to form. Right. So, two carbonyl, why is two carbon is there? So, this two carbon along with the two oxygen will going to get removed. See here, two carbon is there and this two oxygen will be going to get combined in that fashion. And one oxygen which is remaining, that will going to get combined with this water to form a byproduct called as hydrogen peroxide. Hydrogen peroxide. I repeat once again, what is happening over here? When the ozonoid is treated with boiling water and zinc, so that time this ozonoid will lead to the formation of carbonyl compound. Carbonyl carbon is having a functional group in this manner. Okay, so that time it will form the carbonyl carbon compound, and here two carbonyl carbon will be going because two carbons are there. With this two carbon, two oxygen will go by formation of double bond over there. Now one oxygen which is left, that will go and get combined with the water to form a hydrogen peroxide H2O2. Okay. Now the second time what is happening over here is that in second way the ozonoid will react with zinc and acetic acid. Zinc and acetic acid. So here in second way it is getting reacted with zinc and acetic acid. So when it is getting reacted with the acetic acid and zinc, so it will again form a carbonyl carbon, two carbonyl carbon. It will form the cleaving, the breaking of bond will take place in such a way, two carbon along with the two oxygen, it will get separated out, and one oxygen which is there in acetic acid, the hydrogens are there. Acetic acid is having a formula so called, this is carbonyl carbon, right? Now acetic acid is having a structure so called as CH3COOH. Yes, this is acetic acid. So when it undergoes dissociation, here the hydrogen ion will get set free, right? So there are n number of hydrogen ions which are present in that solvent. That hydrogen ion will be going to get combined with the remaining oxygens, n number of hydrogen ions which are there, they will get combined with the remaining number of oxygen to form water. To form the boiling water and zinc to yield the carbonyl compound along with the hydrogen peroxide. The another way that the ozonoid will react with the zinc and acetic acid to form a carbonyl compound along with the water. So this is how the ozonolysis process will take place, and this is two-step reaction. In first step, the olefin will react with the ozone to form an addition complex which is called as ozonoid. The ozonoid will take in this manner. Okay. Now the ozonoid which has formed, it become quite an unstable addition complex. It will further undergo treatment in either way, two ways. First way that if it is getting treated with the boiling water and zinc, it will form a carbonyl carbon and the hydrogen peroxide. In second way, if the ozonoid is getting treated with the zinc and acetic acid, it will form the carbonyl carbon to carbonyl carbon compound along with the water. So we have completed with two topics. So called as first one was the Birch reduction, where the partial reduction was taking place, and the catalytic reduction, where the alkene or the olefin was going to get formed from the alkyne in transform and the cis form. Whereas in the second topic we emphasize upon the ozonolysis. The lysis of ozone molecule will be going to take place. After getting lysis done, that O3 molecule will be going to get combined with the olefin to add certain addition unstable complex called as ozonoid. And that ozonoid will further undergo the further reaction. Okay, so that was all about the ozonolysis. Now we'll understand this ozonolysis process by taking certain example how we understood the general reaction. Let's understand by taking the example for it. Okay, so example. So here we are going to consider one reactant which is basically an olefin. That olefin will be going to undergo a reaction with the ozone to form an ozonoid, and the ozonoid on further reaction with the boiling water and zinc, it will form the 2-carbonyl carbon compound. Okay, so how this reaction will take place? Let's consider one example. This is CH3, a molecule wherein I'm going to consider over here. Okay, so this is an alkene. And the name of this alkene will be as such. So here, how this alkene I have noticed this. It's very simple, children. So what I did over here, if this is the general formula, the functional group for the alkene, what I did is that in place of this hydrogen, here the methyl groups I have substituted simply. And this is just the vertical form. This vertical form I have written in the horizontal form. We just can play with the structural formula of that particular molecule. Okay, so this is how the initial functional group was there, that has been converted into a certain molecule whose name will be as such. Whose name will be, you just have to select the chain, longest carbon chain. Now this is the longest carbon chain. So the numbering will be 1, 2, 3, 4. Okay. Now at third position, methyl group is there. So this will be 3-methyl. Now after that, the 4-carbon chain is there. That means what is the name of this olefin? Exactly, butene. But butene means what? The position of double bond is also very necessary over here. The double bond is situated between carbon number 2 and carbon number 3. So thereby its name will be but2ene. Okay, so this becomes the alkyne nomenclature for this given compound. Now this alkene, when it is treated with the when it is treated with the ozone, it will form an unstable addition complex which is called as ozonoid. So how this ozonoid will get formed? This O3 molecule is there, no? That will be going to get combined between carbon number 2 and carbon number 3 only, because the double bond where it is there only this ozone molecule will be going to get combined. We are not supposed to touch this carbon number 1, carbon number 4. Okay, this methyl group will be as it is, which is the hanging branch group, that will be as it is. take place in such a manner that the O3 molecule will be situated in this fashion. Situated here. So when you are writing the ozonoid, the bond will be going to get broken down and 3 oxygen molecule will be going to get substituted or present in this fashion. This carbon, okay, that will be as it is with 2 methyl group over here, right? So here, yeah, exactly this, right? 3 methyl group, 2 methyl groups are there at carbon number 3, right? So this is carbon number 3 and this was a carbon number 4. This was as it is because the addition reaction is taking place between carbon number 2 and carbon number 3. So this is carbon number 1, carbon number 2. So carbon number 2 and carbon number 3, there the ozone, the 3 oxygen atom will be going to get combined in that manner, and here the methyl group which was hanging, that will be there, and the carbon number 4 is here only, right? So this is what? This is ozonoid, right? So addition complex which is an acid. Now this ozonoid which has been formed over here, that is unstable, so it will undergo further reaction with zinc and boiling water, to end the carbonyl compound, right? To end basically 2 carbonyl compound. Now the carbonyl compound will have the formula, with first one is this one, which is called as aldehyde. Aldehyde, you guys know this thing because this is there in your 12th standard. The aldehyde will have the functional group with RCOH, whereas this is an acetone. If here in acetone, 2 alkyl group will be there. This 2 alkyl group may be similar, they may be different. Okay, so in place of hydrogen, 1 alkyl group is substituted, then it is converted into acetone. So these are the 2 carbonyl-carbon oriented compounds. These are the 2 carbonyl-carbon oriented compounds. First one is aldehyde with the formula functional group RC double bond OH. The second one is ketone. Okay, basically it is not an acetone, it is a ketone. It is a ketone. If we write the acetone formula will be going to get formed over there. That we write down ketone. The ketone. Okay, so this is the ketone with the functional group R, C, double bond O, R. Okay, so these are the functional groups with the carbonyl carbon over there. Carbonyl carbon compound it is. I can say that. Okay, so this compound will be going to get yield over there. How it will be going to yield? Let's see over here. Now here, first we'll end with the aldehyde. Aldehyde was having the formula R, C, double bond OH, right? So R means alkyl group. Okay, now when alkyl group is there, the cleavage will be going to take place in this fashion that R group is what? R group is alkyl. Which alkyl group is there? Methyl. Okay, let's write down this methyl CH3. Okay, then what is there? This oxygen. Okay, one of the oxygen will be going to get combined over here. Now one oxygen which is there, that will be going to get combined over here to form carbonyl-carbon and then hydrogen. So what is this? This is the aldehyde, no? The functional group R, C, double bond H. So the name of this aldehyde is acid. Acid group is there, acetate. If we say that, so that time it becomes acid. Aldehyde. The name of this aldehyde is acetaldehyde. Okay. The another, carbonyl compound will be going to arise over there, and the name of that is basically ketone with the functional groups as such like this: R, C, double bond O. So this is the ketone, right? Which is again the carbonyl compound. So this ketone will have 2 alkyl group, right? 2 alkyl group and 1 carbonyl carbon. So 2 alkyl group, where are we going to get over here? Yes, this one you can see over here. So C and 1 carbonyl carbon, right? So 1 carbonyl carbon will be there and 2 alkyl group will be there. So this carbonyl carbon with oxygen, you can see over here. are going to get combined in this manner to form a ketone whose name is acetone. The name of this ketone is acetone. Initially, which I wrote over there, this is that. Okay? Okay. So that is an acetone. Then here CH3CHO1. Then here CH3 twice O1. Then only one oxygen is remaining. That one oxygen will combine with this water to form the byproduct which is called as hydrogen peroxide. The byproduct called as hydrogen peroxide. Okay, so this is how the reaction is going to take place. This is really very important reaction from the examination point of view, and they may ask you yield the aldehyde and ketone by osmolysis process. The question may be in that manner also. Give the reaction for the preparation of aldehyde and ketone by osmolysis process. So that time you need to consider this example, which is very simple and very interesting as well. So we have been winded up with the osmolysis with certain two steps with chemical reaction as well as with the example we took general reaction and example we took. And apart from that, earlier we studied the preparation methodology, right? We are undergoing certain preparation methodology of alkene from alkyne. That also we studied. So hereby we winded up with this session, which is session number 7. So first we studied the preparation method. Second one is osmolysis. These two are really very important, children. So study hard, practice this